we will see how to use vLLM with Llama 3 model. So first I will show you that there is certain prompt format and template which Llama 3 model uses, which we need to understand first. So first I am creating one tokenizer object, okay, using the Hugging Face library. So you can use any model ID you want. You can create a tokenizer object. Okay, so the Llama 3 accepts the input prompt in this format. So we have three different roles: system, user, and assistant. And we can give one system message, and okay, and there will be a continuous chain of conversation between user and assistant. User will ask some question, assistant will answer, then again user will ask. So you have to use this format if you have to pass a single question answer format, or even a chain of uh, conversation. But the actual llama model will not take this format. It will first tokenize it and add some special tokens to them. So to know which special tokens are applied, we will use this tokenizer object we created, and then we will apply this chat template. And you will see after apply the chat template, it looks something like this. So I have printed the prompt. Okay, so for every header like system, user, and assistant starts with this start header ID, end header ID. Then prompt start with beginning of text, and then every content of user or assistant will start with sorry, not start, will end with EOT ID. So while passing prompt to the llama model, we have two ways: either we can directly format our prompt in this format, or we can uh, use this format, then use apply chat template for the llama 3 tokenizer, and then get our prompt in this format. So for this tutorial, I will be using this format. Uh, and one more thing, like Llama 3 has this format. Llama 2 used to have some different format. Like for instruction used to start and end with this inst and inst end, and you can go through the difference between both this template and just okay. Whenever you are switching between models, just check what is the prompt template. Okay, now once our prompt template is clear, so I am taking this example for this tutorial. So I am asking to give a three-level categorization of some product in this format. So I am going to use the format method, which will replace whatever is inside this curly brackets to whatever input we want. And I wanted to keep this curly bracket in the prompt. Therefore, I have added this double curly brackets. So whenever we pass any product name like Siemens electric motor of 5 HP, it will get converted in this uh, prompt format. So these curly brackets are present, and the single curly bracket was replaced by this. Okay, so this is our prompt which we are going to use. Okay, and this prompt format. Now after we have installed the vLLM, we can then uh, download the model using vLLM. So same like Hugging Face, we have to pass the model ID, or you can pass the local path where your model is stored. So it can be the model you are downloaded from Hugging Face, or your own fine-tuned model, anything which is saved in your local system, or in your local EC2 instance. The path can be given here. Okay. So the main thing about vLLM is that whenever we so for this example, I am using this Llama 3 8B con- contest model, AWQ contest model. The total space this model takes on the GPU is 5.3 GB, and vLLM will use some extra memory which we have, GPU memory which have to store some extra KV blocks in them. So I will not go much into theory how vLLM works and how it is able to do continuous batching, uh, use page attention to store the KV key and value pairs and everything all those things. So one thing I wanted to tell is that if you're not using vLLM, this contrast model will take space of 5.3 GB. But when you use vLLM, it will use all the balanced GPU space, but it will offer you a great boost in speed. So you have to check whether you have some GPU space available. Like for this T4 GPU, if you are using the non-context model, it will fill the whole memory. So for using vLLM, you have to go to some higher next GPU, which will have more memory. So now with context model, we can use this. So when I'm creating this LLM object, there is one parameter, this GPU memory utilization parameter. So I have set this to zero point 0.7. So it will only use 70% of the GPU memory available to load the extra KV cache. We can, for this example, I have just taken 70%. So you can change that based on your available memory and how much free space you need to perform some other operations or to save some other model. And if you fill this GPU memory to the upper limit, then anytime you can face out of memory error. So based on your application, decide how much this parameter should be. And there is one more parameter known as max model length. Here I have just taken 1500. You can vary that based on your, means you have to vary that and check that how is your output quality improving, how much space after loading of this vLLM model with various max length it is taking. So the more the max model length, the more space it will take. So by default, the GPU this GPU parameter is 90% and max model length is default model length. So now Llama 2 has 4096 model length and Llama 3 has 8000. So you don't want the whole model length for your application. Sometimes our application may need very less model length. So you can try with various number like 1024, 2046, or even less than 1000 and check for which model. The less the max model length, the better it is for you because you will have more space to work for the vLLM. So these two parameters you have to adjust, and there are many other parameters from for for this stage. You can just go with these two parameters. So as I told, without vLLM, it was taking 5.3 GB. After the 70% GPU parameter, now it is consuming about 11 GB of space. So I have now sufficient amount of space available to do some extra or operation or load some other model. So now once we have our LLM object ready, we will now set some normal parameter. So I will make a separate video about this temperature, max token, and top P and top K, all these parameters. So once all these parameters are set, we can now call our generate method on this LLM object and pass our prompt. Now in this case, I am only passing a single prompt and passing the parameters. So you can see it took about 4 seconds to generate the output. And output is looking like this. This is the output format. You can go through the structure of the output format and parse to get your output. So you can parse out and output will look something like this. Okay, so it is given us three level of categories and it is also pasting some other text here. Okay, so when I tried the same input without LLM, without vLLM, the contrast model was taking about 10 seconds to give the output. Now with vLLM and also being very conservative with amount of GPU to be used, I'm able to get this output in 4 seconds. Now I purposefully designed this example with this format. Means based on your use case, you can just think about that. We have one parameter in sampling parameters known as top token. So now I will just tell the vLLM to stop at this token, this curly bracket and three quotation marks, so that our generation length reduces, because the most of the major time it takes for LLM to generate output, the output token. So all this output here, breakdown, each level, all these words, it has to recursively pass through the model again and again, again and again. So we can just stop our generation here, and when we do that using this parameter stop and include stop string I have set to true, it takes only 2 seconds to get output. Yes, so only half of the output was required, and we have used the stop token. And okay, we were able to get output from in 2 seconds from 10 seconds. Okay, so that is one feature of vLLM. Like we have in GPT models also these features. And the one more main thing about this vLLM is that you can batch prompts, and the speed improves much after batching also. So many times we have application where we have to do some offline processing of various prompts, like we must be having 10,000 number of prompts which we want to process in offline mode. So now I have taken this example, I have taken these 5 products, I will just pass them to the prompt template and get list of those 5 prompts. So initially for single prompt it took us some 2 seconds with the stop token, 2 seconds to get the output. Now when I run this in batch, so instead of prompt I will pass this prompt list. You can see in this printed verbose that there were 5 inputs and all 5 were processed in just 3 seconds. So if I divide this 3 by 5, so instead of 2 seconds, now each prompt was processed in just 0.66 seconds. Okay, if I instead of 5, if I take so you can see this output. Okay, so it is working in batch also, it is giving the expected output. So you have to play with prompts and see which type of prompt gives you the answer. So now instead of uh, 5, I have taken 15 prompts, and it was able to process 15 prompts in 4 seconds and 30 prompts in 7 seconds. So see, 30 prompts, each prompt took only 0.2 seconds. So from 2 seconds, if you do batch processing, so you can read about continuous batching in vLLM. I will also try to make a separate video about the theory of vLLM. So when you are batching prompt, like batch of 30 is just taking 0.2 second, and total 7 seconds. So after a point, you can for your specific use case, you can go on increasing the batch size, and the amount of time it takes to process the prompt goes on decreasing, and after some point it will become stable. So you can find that stable point and then fix that batch size, and accordingly just do your offline processing in very less time. So it will, so if you are using any serverless system like Fargate or AWS batch to do your offline processing, okay, you may, like there you may save your time by using vLLM, and also save on cost. Okay. So this was the whole video about vLLM, how to practically use that. And one more thing, this is taking 0.2 seconds here on the Colab notebook. So Colab notebook are usually slower than the actual server you will use. So if you are using any EC2 server from AWS or from Google Cloud, okay, it will be, the speed will be even less than this. Okay, so 0.2 second is a pretty great speed. But if you are able to use batch, if your use case does not allow for batch, then also it is taking only 2 seconds. So means you can say you can get a lot of boost in latency by using this vLLM. Okay, and accordingly you can decide, okay, whether if you have extra GPU space or whether it is worth to